Let's now see the infusion. Things are fairly simple here. Friction hardly occurs at all since BSS is not viscous, and there are no compliant forces since there is no depression. The only elements in play are the gradient of pressure and the internal diameter of the tubing. The gradient of pressure is linked to the pressure of infusion, which in turn depends on the height difference between the drop counter of the bottle and the eye. When there is no escape or aspiration, an immediate equalization occurs between the infusion pressure and the intraocular pressure. These two pressures vary according to the height of the bottle. If a leakage or aspiration were to occur, the intraocular pressure would decrease, causing the gradient of pressure to be responsible for the infusion. This infusion will be proportional to the diameter of the tube. Bidet and Collin confirm these facts. In the absence of aspiration, an infusion of 70 centimeters carries a pressure of 51.7 millimeters of mercury in the eye and throughout the aspiration tubing. This infusion pressure is responsible for a flow of 36 cc's per minute in the air. The frictions in the eye diminish this flow to 23 cc's per minute. The frictions at the level of the handpiece, as well as the aspiration tubing, further reduce the natural flow of BSS at the start of the pump to 8 cc's per minute. Two surgical consequences become evident. First of all, for a bottle at 70 centimeters, when you connect the infusion tubing tip and open the infusion, the intraocular pressure is going to be quite large. One certainly needs a good infusion pressure in order to obtain an infusion flow that is sufficient enough to compensate for the aspiration flow. However, if one raises the handpiece without having clamped the infusion, the intraocular pressure that had established itself will cause a vitreous incarceration, a serious complication. Thus it proves absolutely necessary to control the infusion with the pedal, as in Phaco. Secondly, seeing that a gradient of pressure of 51.7 millimeters of mercury between the bottle and the pump already carries a natural flow of 8 cc's per minute, if one were using a Venturi pump, it would only be possible to add an additional depression, resulting in a higher gradient of pressure and thus a higher aspiration flow, greater than 8 cc's per minute. The minimum flow, when using BSS, for a depression of only 5 millimeters of mercury, will be 8.4 cc's per minute. Only a debimetric pump, like the peristaltic pump, thanks to the slow rotation of the rollers, will be able to slow down the natural flow of BSS. This will also allow one to control the water flow from 0 to 8 cc's per minute without